Good afternoon, Chairman and everyone. Today I would like to present the construction of point cloud data for road maintenance. My name is He Qiyuan from Kansai University at Japan. So I set this talk into 5 parts from background to construction. And I also put some photo of our survey site on the right, on the outline of right-hand side and enjoy of it. And the first part is background. In Japan, there are many road infrastructures has been built over 50 years ago due to progressive deterioration in road infrastructure. Ensuring proper maintenance of overall facilities to avoid potential problems is an important issue. So, in order to avoid and reduce substantial loss, deal with an emergency, prevent damage, and emergency disaster control, and carry out disaster recovery, road administrator must maintain roads more efficiently. In current maintenance work, road administration facilities are represented on 2D map, which is not suitable and not convenient for correct repair, inspection, or annual overhaul. Construction of an environment to image 3D data and maintenance information for planning, design, construction, and rehabilitation of road functions is necessary. And the next is proposal. In this research, using 3D point cloud data to build road maintenance framework is the proposed. Use the UAV and the TLS TLS and UAV photogrammetry technologies to survey road structures. Using the 3D data to improve operation and maintenance more efficiency. To check characters and suffer irregularities to prevent and can be easily and quickly. Using 3D cloud data to the Shiraido Highland Way in Japan for management. The third one is methodology. As we know, which are a number of survey models for constructing 3D data using laser imaging detection and ranking like MMS or TLS, and photogrammetry using camera by UAV. So we combine the 2 ways of survey method, UAV and TLS, according to the site situations and both surveying civil structures, construct 3D point cloud data and use it directly. So understanding the characteristic and specification of choosing suitable point cloud data for road maintenance is important. And as we know, point cloud data are generated by aerial photogrammetry or a video output camera on UAV. The data are generated by using structure from motion. We call it as FM process. And according to our survey site, using TLS to survey the upside of a slope is difficult. TLS has limitation because the angle of the slope. Therefore, the upside of the slope or a landform is surveyed using a camera mounted on UAV. As you can see, and this at the left-hand side is TLS point cloud data, and the right-hand side is UAV data. And over the slope is cannot not clearly. So we use the UAV and take a video and separate it to photo and use software to construct the UAV data. And this is a point cloud data, not a picture, so you can see it is better than TLS. And next is the raw maintenance information system, which use point cloud data, is defined by definition of information system. By definition, an information system collects, processes, transfer, and utilize information in own domain. So on this research, we compile it into a form based on this experience. According to the law, the least conditions with the disadvantage and advantage of the TLS and UAV, it may be helpful to obtain high precision point cloud data. And fourth, we also consider about the definition of raw maintenance information system. In the definition of raw maintenance information system, which the system can be constructed that we can combine the system and the point cloud data according to the situation, make a suitable plan for raw maintenance. So we set the idea into 4 parts, from collecting the data and processing and information transmission, and finally that we can use the data. So let me explain the definition of that. Information collection is the point cloud data for raw of infrastructure are collected using TLS and UAV-based photogrammetry. And also we now current, we use the AMS to survey. And the second one is information proceeding. Point cloud data generated by TLS contain noise data, so concerning trees and vegetation on a road. Information processing such projects should be removed in order to represent raw structure accurately. And the third one is information transmission. TLS and UAV based on photogrammetry each have distinct characteristics: survey time, something like survey time, and scan range or accuracy. While area and high precision point cloud data are generated by combining each set of data units, compared to different temporal data unit for analysis. And the next one is usage of information. Raw maintenance information system is proposed, which has function for detecting characters and superimposing photographs based on the point cloud data. And this is the image of the information system. So the fifth one is the measurement. We separate it into prevent and bridges. So there are some limitations discovered on this survey. We pick them up. According to the result, a survey on site limited has been discovered. The first limitation is on site circumstance, and passengers and cars passed by the road being surveyed during the measurement. Therefore, have to pay attention to surveyors and the instrument and to determine measurement range and occurrence for the set of circumstances. The second limitation is measurement range according to experimental results. High density measure range is restricted to within about 10 radius. And this shows about in the a row of site is a lot of tree, so it make the result we can just the measurement range is about 10 meter radians. Also, the specifications of instrument claim about it can survey 300 meters. And as you see, the picture of right-hand side is is combine the TLS and UAV cloud point cloud data after processing. And the point cloud data is contain about 30 million points. So in order to construct the 3D data for upper and lower of bridge, and this part is saying about bridge. After we survey the Megata Bridge in Kishiwada City in Japan, we combined UAV, SFM data, and TLS point data. Combine SMF based on the TLS data and delete unnecessary parts before combining. And combine the 50,000 features point of each data and construct into one 3D data. And as you can see, the upside and bottom works of bridge, they could be accurate. And we also compare the point cloud data of Waratsuhara Bridge within design conditions. And the inaccuracy for the bridge is effective length of 12 millimeters and effective width of 19 millimeters. And it seems the point cloud data describe the structure of bridge with high occurrence and high precision. And finally, the conclusion is that if the point cloud data could be linked inspection result with information system for plane storming and referring, it can make maintenance become easily. In the future world, point cloud data can grasp change in shape and condition of damage due to spatial and temporal management. So this is the point cloud data, and you can see there's some characters over there. So we concerned about we want to build an information system that can recognize the lines, and the maintenance staff can use the information system and check the point, check the correct point, and repair it. Okay, my speech is all. Thank you for your attention.